Alright everybody, this is chapter 13. We're going to talk about aggregation, composition, actually in the opposite order, and inheritance. Okay, we're going to cover, actually, I'd say half of this chapter is all about aggregation, composition, and UML diagrams. So we're going to walk through that, and then we're going to continue on with inheritance and a few other items, excusing, overriding, constant, stuff like that. There's a bunch of sample programs this week, and we'll be going through them as well. So let's get started. Okay. Composition. I'm going to read a couple of these slides because actually the definition is really good. I know a couple of you think that, well, he just really doesn't provide much beyond the chapter or beyond the slides. Well, some areas I do, some areas I don't. Okay? Since prior to this chapter, everything's been pretty much simple. Okay? Now what we're doing is we're actually bringing in more complex objects. Okay? It says, but for an object that's more complex, you should consider breaking them up. Rather than having one huge 1,000-line program, try breaking them up. Okay, actually, I'm going to try to find something real quick here. Alright, I just found out what I was looking for. A few years ago, I was attending a class. Now, if I can only get the thing on the screen, I got like 47 windows open here. Back up to the top one. Okay. I was attending a class at University of Tulsa, and it was called compilers. And you can see there's the actual structure of the files I was working with. When I was getting near the end, I actually started making copies of it quite frequently because I was worried about losing it. I'm going to open up a few of those for you. Okay. I'm opening up project 3 right here. And you see there's lots and lots of stuff in there. And have you ever taken a compilers class? Well, this is portions of it. I did things like I had to make a lexical analyzer. Okay. So there's a portion of that class. And this entire one, this is actually a main component of the program. It probably was about 1,000 lines long, maybe a little bit longer. But this is, I would say, the main driver of the program. But there's a bunch of smaller ones. Let me show you some smaller ones. There's the individual machines, and that one's considerably shorter, as you can tell. That one's like 200 lines long. Let me get into, let's find out, how about a node? Node is really short as well. That's 200 lines long. Again, you might think 200 lines is long, but in the real world, it's not. Okay. How about the parser? The parser should be pretty long as well. This is the one that actually reads through all my other classes, and it's quite complex. That's about 1,800 lines long there. And let's see, this was written prior to the scanner class, so we actually had to write the code to get input. So that's a while ago, obviously. Let's see, how about a stack? Here's my stack list. I actually used a vector. I think I did. Let's find it up here. Yep, I sure did. We've learned about linked lists and array lists so far, but there's actually something called a vector, which I used as well. So there's just a whole bunch of different things. And the different tokens in here. Again, that one wasn't very long, but it was somewhat long. Just lots of different codes. And a subnode. And that one's really short. That one's, what, 130 lines long. So my point is here, this program which I had to write, oh, there's a black node. And there's also a red node. The black node, I think it was black and white. Was it black and white? Let's see. No, maybe it was red. Black node, and there's another color node, darn it. I can't find it here. Well, one of these, there's a stack node, there's a sub node. See, that one's quite short as well. Can't find the other color, but it was quite complex, as you can tell. Alright, let me close out a few dozen of these, since we don't really need these anymore. But the point is, this program was complex. Had lots and lots of pieces to it. And yeah, some of the code was long. Like you saw, what was that, 1,800 lines long. But overall, I broke it into different pieces. I broke the parser apart from the lexical analyzer. And each one of those called the node, which was kind of like an instance of an object I needed. There's just lots of different pieces. So what you do is you break it apart. It says when the whole class is an exclusive owner of the part classes. So what they're talking about here is with composition, the class is, like I said, when the whole class is an exclusive owner of the part classes, then it has what's called composition. Okay? So since my program actually was the owner of all of the subparts that had composition, okay. Whoops, I gotta click here so I can move on. Okay. Yeah, and actually before I go on, it's really called exclusive ownership. Okay. It says the parts of the classes can't be owned by anyone else. Now, in our programs, we use the scanner class. Okay, that becomes a part of our class. But do we really have exclusive ownership of it? No, other people could use it as well. Okay, let's continue on. Okay, it's not new, right? But it's basically what we do to describe complex items. Okay, and we're going to see an example of one here in a minute. Okay, because every living creature and most manufactured products are made up of parts. Okay, I drive a Chevy Volt. I don't know if any of you know what that is, but that's the electric car. It's amazing. I did get gas, I think, in March 2012. I think that's when I got it. Sometime late spring, summer 2012, I bought some gas. Still got a quarter of a tank, by the way. But that really doesn't matter to anything. And when I'm recording this, is actually summer of 2013. So we're over a year now. But my point about that is that car has like 39 separate computers in it. It's made up a whole bunch of parts. Right? If you remember way back when with Henry Ford started the whole assembly line, it really changed the way we did manufacturing because then we just took all these parts of cars and put them together. Well, everything's done that way now. There's a show How It Works, I think it's called. I always like to go in there and watch them make even simple things like Cheetos or bread. It's just amazing on how those work together, okay? But let's look at the next part here, okay? Let's go to the next slide. Here we have the human body, okay? It's a partial composition of the human body, okay? You'll see we have the body, has a brain, a heart, a stomach, bones, muscles, cells, and it goes on from there. So the muscles have cells have nucleus, and they have the mitochondria, and you know what? I am not a scientist. Yay, that's why I'm computers. We have molecules in them, so it can be breaking down much farther. Let's go back for a second. So, we saw the hierarchy. Okay? It says, with a composition relationship, a component part is limited to just one owner at a time. So if we go back over here, you'll see we have a heart and a brain. So, a brain. Well, actually, let's go with the heart. Right now, my heart is inside of my body. So I am the owner of my heart. But does it have to stay that way? Could I donate my heart to someone else? Yes, I could. So it really, like it says here, it says, remember that when a composition relationship, a component part is limited to just one owner at a time. For example, the heart can be only one body at a time. Okay? Let's move on. Now let's talk about aggregation here for a second. All right, the difference between aggregation and composition. Okay, with composition, remember, like it says, let me go back 2 slides. It can be owned, like at the very bottom here. A component part is limited to just one owner at a time. Okay, now let's go back over here. It's not the same with aggregation. Okay, we still have a relationship between the two. But there's no, like it says right, there's no additional constraints that require parts to be exclusively owned by the whole. Okay? Alright, so as an example, it says you can implement a school as an aggregation by creating a whole class for the school and part classes for the different types of people that work in the school. Okay? It says the people aren't exclusively owned by the school because you really only work there or go to school there. Okay? So just because the school has students, does that really mean that the student is owned by the school? No. So it says a person could attend classes at 2 different schools and be part of 2 different school aggregations. Or we could even break it down farther. Maybe we had our program where we had classes rather than school. Okay? So now you actually attend 2 different classes at the same school. Or 2 different classes at 2 different schools. Or so on and so forth. Okay? Says they might even be part of a 3rd aggregation, like a household aggregation. So they do change quite a bit. So you can have different things work with minis. Now, this next thing we're going to talk about is a car dealership program. It's actually quite long. Okay. So suppose you're trying to model a car dealership. It's kind of funny because I bought a car, obviously, at the car dealership. I've done a lot with them. But I always think it's funny that we have a GM dealer and a Chevy dealer and a Toyota dealer all owned by the same owner. So they're really the same, but they have individual parts, so they share them. Okay? It says the car dealership non-trivial parts are groups of cars, a sales manager, groups of salespeople. Okay? So if we're going to make this program, like I said here, we should have a car, a manager, a salesperson, a dealership, so on and so forth. Okay? So we have the dealership to car relationship, the dealership to salesperson, the dealership to manager, but you also need a customer. Okay, so there's a lot of relationships within the program. Okay, this is the UML. Okay, let's talk about this for a second. The solid line between the two classes represents association. So we have lines here between the items, between the dealer and the car, and the dealer and the manager and the dealer and the salespeople. Okay, and the association line. Okay, says a solid diamond, like this guy right over here, indicates a composition relationship. So basically, the car is owned by the dealership. It would kind of hard be the car to be owned by two dealerships, but it can actually happen. Like my car, when I bought it, they actually sold it to me at my dealer, but they didn't really have it at my dealer. So they sold me a car they did not own. So what they did is they went and swapped out cars with one up the street. So, still, I realized the car did belong to one dealer at a time. Now, you also notice the 1 and the asterisk right here, okay? This is like a one-to-many. If you ever taken any database classes, this is kind of the same thing. So what this is saying is one dealership can have many cars. So one to many. One dealership can have many cars, okay? One dealership should have one manager. Now, does that mean there are not other managers? Well, there's really one guy in charge. One dealership can have multiple salespeople. Okay. So the solid line, which says the association line with the solid line, is a composition relationship, and the hollow diamonds, like here, like for the salespeople and the manager, are an aggregation relationship. Okay. All right. This is we already talked about the values, talked about the one to many, so on and so forth. Okay. Says to implement the car dealer, we need aggregation and composition. Okay, it says define one class for the whole and define separate classes for each of the parts. Okay, so if we were making a dealership program, would we have the dealership, a multi-thousand line program? No, we would want to have the dealership, then we want to have the manager, then we want to have the car, 8 separate components that are, like I said, separate from each other. Okay, and just like we saw in the picture here, the car, the manager, the salesperson, all those are separate. Okay. All right, so it's typical for associations with multiplicity values. Okay. All right, asterisk. We talked about that already. That's one to many. Okay. Sometimes you'll actually see this asterisk, written like an infinity sign. Okay. But again, that's more like in databases, but it's the same kind of deal. Okay. It'll be more like an infinity. Okay. If two classes have an aggregation relationship with non-exclusive ownership, then store the container's objects in an instance variable in the container class. Okay, we talked about instance variables already. That's a long time ago in other classes. So if it's something that pertains to it, store it in the instance class. But also store another variable outside the container class so the object can be added to another aggregation. And we're going to see that here in a minute how that works. Okay. So if two classes have a composition relationship now, then store the container objects in an instance variable in the container, but don't store it anywhere else. Again, we will be seeing how that works here in a second. Okay, the next bunch of slides goes through the program. I'm going to bring the program because I made it already. Well, I didn't make it, I copied it already. Okay, so we can look at it bigger here. Okay, here's our dealership program. Okay, so we start off. Obviously, you can see we're using an array list. We have a prologue at the top. Okay, so some of you leave comments about prologues and stuff like that. So is this prologue decent? Let's see. Well, it's got the name of the file. It's got the programmer's name. This represents an auto retail sales organization. Short but sweet. Okay, actually, while we're here, let's look at one of the other ones. This class implements a car. This class implements a sales manager. Okay. I could live with those. I do like a little more comment in there. Okay. This class demonstrates the car dealership composition. Okay. But when you're writing, the whole point of this prologue, so I used to work on software development over in the military. we'd go through thousands of lines of code, sometimes program after program, and we don't know which program's doing what. So we should be able to look at the very top of the program and get a good idea what it's called, who wrote it, and what it does. Okay, so this helps us. We understand, but it really doesn't tell me a lot about it. Again, this is just an example, but it does help to put more in there. Think of it, if you were going to look at this 5 years from now, just by looking at the top section at the prologue, would you know what this program does? Okay? All right, let's go on down here. Okay, so we have an array list. We have our class called dealership. You notice they match. Okay? Then we have the company name. It's a string. We have a manager name. Now, you'll notice company is of type string. Manager is of type manager. Okay? Now, if it was manager name, it could be string, but we want to have a separate object for manager, so a separate class. So manager is of type manager. Then we have an array list. We have an array list of people. Okay? What type are the people? Salespeople or salesperson. Okay, we're going to look at that class. Then we have an array list of cars. So why are we using array lists in these two lines here? Well, let's look at salespeople for a second. How many salesmen work at your dealership? I bet it changes. I bet it changes based on time of year, cars being released. So an array list is good for that. We can have one or as many as we want. Easy to search through, easy to remove an item. Whereas if we had a normal array, okay, say we make an array of 100. We're probably never going to have more than 100 salespeople at our dealership. But people do come and go. So if I delete someone out in the middle of an array, now we have an empty block in the array. An array list kind of takes up that space. Same with the cars. How many cars are we going to have? An unknown number. So that we want something that grows. Okay. All right. Here we have public dealership, and you should remember from prior classes that that is our constructor. This is a constructor that receives two parameters, the company and the manager. I notice the company right here gets stored in the company variable right here. Now we know it's private. Private means it can only be accessed from inside this dealership class. Okay, so company gets stored in company, manager gets stored in manager. Since we are using the same names, we have to use this dot so we can reference the ones at the top. Okay. Then we're going to add a car. So we have a method. Now, we have some called access or mutator methods. Here we're adding a car, so we're really mutating, we're changing the number of cars we have. Okay, the add car method returns nothing. Okay, it's public, anybody can access it. And it receives a car. And it calls it car. What type of variable is car? It's a car. Just like up here, what type we're receiving manager as an argument. What type of variable is manager? Oh, it's manager. We received company. What type of variable is company? Oh, it's a string. So what type is of car? It's of type car. Okay. Now, we're doing cars.add car. Now, what is that? Well, if you remember up here, you can actually see on the same slide, cars is an array list. Remember, it's an array list of type car, and we're calling it cars. So now we're saying, hey, cars, which is my array list, they match right here, cars.add car. So this is calling the add method from the array list. Think back, I think, 2 chapters ago, or maybe 1, I can't remember. No, 2. And add an element of type car. Actually, not of type car, add car, because car is right there. Okay? Now, let's get down to add person. Okay? Add person works kind of the same way. Remember, we have a salesperson array, an array list right here. It's called people. It's of type salesperson. So we're going to get down here, and we're saying the person is of type salesperson. Okay? Remember, salesperson is another object, a class we're going to look at in a second. And that person will be added to our array list called people. So here's where we're adding to our array list. So all the work of adding cars, adding people is done all right here. Okay? Kind of makes sense. If I was running a dealership, would I want anybody to be able to accept a car into the organization? Probably not. Would I want anybody in the organization to be able to hire somebody? Probably not. So you want it all done by one place. Okay? Now, I want to print the status. Okay? System.print line, the company name. Again, the company comes from the variable here, company. Company, and you'll notice the /T. Remember, that's an escape character in a tab. Now they have it in double quotes, which means it's a string. Okay, just like some of you should have known from the last program. Company, tab, manager.getName. Well, we don't have getName. We don't have getName anywhere. Well, manager, let's see what manager is. Manager is a variable right up here. What type of variable is it? Oh, it's a manager variable. So what that's telling me is manager with a small m is of type manager with a big M. So manager with a small m obviously has a variable called getName. So now I happen to have the manager class right here. If I go here, let's go on down. Oh, wow, look at this class. It's really big. There's our getName variable. I'm sorry, method. Okay, this is an accessor method because it's accessing the name. You see, the manager class is very short. Public class manager has one variable, the name. Could we hold more information about our manager? Sure, we could hold his address, his phone number, and all that stuff. But, for this class, we don't need it. And the nice thing about doing it this way, if we wanted to start working with his address and his phone number, we could add it all right here inside the manager class. Okay? So getName just returns the name. Okay, let's go back to dealership. So now we know we got company, we got the manager's name. Then remember the for each loop? For each person in people. What was people? Remember, people was our array list. For each person in people. What type is person? Person is a salesperson. So for each person, what it does is it takes this array list, and for each item in it, we get the name, and then we get the next name, and then the next name, and then the next name. So this is going to go for each person inside of the array list people. We're going to call getName. Then it's going to go on to the second one, get the second name, and third name, and fourth name, so on and so forth. And for each car of type cars, for each car, okay, in cars, remember cars is the array list right here, cars. For each car in cars, get the make. Well, we didn't look at the car class yet. Let's look at the car class. Okay, car class. We're storing the make. We have our constructor and then get make. If you look at the manager class and the car class, wow, you noticing anything? They're identical. All they did was change the name. It doesn't mean that we're having multiple items that have to be complex. Now, could car have a lot more information? Yeah. Car could have color and size and price and all that. And manager could have address and phone and all that. But for this example, we just need something basic. So car, very short. Okay, so for each car in cars, the array list cars, get the make. So what we're doing is we're going to output on the screen. We're going to print the status of all our salespeople and all of our cars. Think of maybe a monthly report. The sales manager says, I want to know what the status is of our company. So I want to print out all the people currently working for us and how many cars we have on the lot. So that's what that could be used for. Okay? So that's dealership. Let me move this out of the way. All right. So we talked about the dealership program already. Talked about all that already. Talked about. Okay, now we're on to. We already talked about adding a car. Did we do this one? Yeah, that's dealership. Let me make sure we talked about it. Hold on. Yeah, we added a car. We added a person already. Okay, oh, let me bring this back over here for a second. Now let's look at car here for a second. Does car rely on anything else? Does car extend anything or inherit anything? No, it really doesn't. So I should be able to compile this. And I can. Let's just make sure I'm not lying to you. Let's just make an error. Yep, so you definitely got an error now. So 7 compiles all by itself. Manager should compile all by itself. Now the dealership. What did dealership rely on? Dealership relied on people. We haven't looked at the salesperson one yet, so we're going to get there in a second. Okay. All right, here's the car. We already talked about this whole class, but construct the class car has a constructor for creating a new car and then returns the make. There's our manager, class manager, constructor for a manager, adding a new manager, and then getting the name. Okay. Now let's talk about salesperson for a second. I'm going to bring up here just so you can see it a little better. Okay. Salesperson. Okay. All right. here's our class name, public class salesperson. We have a name, okay? And we also have this double sales 0.0, sales to date, okay? Now, if I was thinking number of cars he sold, would double be a good choice? Probably not, okay? But I'm thinking they're going in dollars. If they're going in dollars, then yeah, double's a very good choice. Okay, so we got our constructor here, salesperson, receives a name, so obviously they're creating a new one. This is what they call new salesperson. Name is equal to name, and again, this name is this name is this, okay? Get name, so we return it. So, wow, that's the third class that are nearly identical. So a lot of people figure, oh my god, I got to write so many classes. Yeah, but look how short they are. They're very, 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 very basic, okay? All right, so there's the salesperson class. Now let's go into the dealership driver. This is going to be the longer one, okay? Actually, let me bring it up here. I happen to have the dealership driver right here. Okay, dealership driver class. Now, we have a main method. Now, oh, that's a very good point. Let me look at these other ones. Let's look at dealership for a second. No main method. Car, no main method. Manager, no main method. Salesperson, no main method. So what does that mean? That means I can take car over here and I can compile it. If I try to run it, no main method found. Let's try manager. I can compile it, but I can't run it. No main method found. Okay. Let's do the same for salesperson. Compile. No main method found. In dealership should give me the same. No main method found. So you do not need a main method in these other classes, but you just can't run them. You got to run them from some sort of driver. Okay. Now we have our main method. Okay. So here we have a new manager. We're saying Eric is a manager. Okay. What type of variable is Eric? Oh, it's a manager. That's equal to new managers. Eric Adlard. Okay. Now, if I go back up to the manager class, see, we're calling new manager passing in a value right there. If I go to the manager class, there it is. The constructor, manager, public manager, we know that's a constructor, receives a variable name. So this Eric Adlard gets stored, comes in a name, gets stored right up there in that variable. So later on, if we want to call get name, what it would return? It would return Eric Adlard. Okay? So there's Eric. Now we get a new salesperson, Curtis. Okay? I don't know if this variable name is really very good, but it does work. Okay? So Curtis, what type of variable is Curtis? Oh, Curtis is a new salesperson. Is of type salesperson. And is equal to a new salesperson, Curtis Bollmeyer. Okay? So let's go look at salesperson. Okay, remember, we're passing Curtis Bollmeyer to the class salesperson. So salesperson, here's our constructor, receives the name. So Curtis Bollmeyer came in under name, got stored in name. So now we have the variable or the name of Curtis stored. Now, do we have a value for him yet? I mean, this whole sales item. No, we don't. But when we created the instance of when we said new salesperson and stored the name Curtis, Curtis automatically got a sales of 0.0. Okay? Because we told it right here. Hey, whenever you create a new one, it's always 0.0. Okay? Okay, now we got Jordan. Same thing. Create a new variable for Jordan. His sales are 0 as well. Makes sense. You get hired at a dealership, you have 0 sales initially. Okay? Now we have the dealership. Okay? So dealership is of type dealership equals new dealership OK used cars, comma Eric. Wow, that one's different. So it's new dealership OK used cars, comma Eric. Let's go look at our dealership class. How do I know it's a dealership class? Because it tells me right there. Okay, in the dealership class, I received, on my constructor, I received a string for the company. So the company is OK used cars. Then I also received Eric. What is Eric? Eric's a manager. So I also received a manager of Eric. So the company got set to OK used cars and the manager got set to Eric. Okay? So far so good? Alright, let's continue on. So we got all that set up. Now we're going to say dealership.addPerson. So the dealership, we have we have some people. We created 2 people up here and 1 manager. Now we're going to add those people. So we're going to go dealership.addPerson. If I go down here to add person, remember we talked about this already. This is where we add to the car array list and add to the people array list. So we add those people. So when I call Curtis add person and Jordan add person, it's calling this method right here add person, and it's adding Curtis and Jordan. Okay. All right. Now we're going to add some cars. Again, we're still calling the dealership. Dealership right here is the variable of type dealership. So we're still calling dealership, but instead of add person, now we're adding cars. An Accord, a Civic, and a CRV. You know what? Well, I guess, are they all the same type? Honda Accord, Honda Civic? I guess this is a Honda dealership. That's terrible. Okay, but we're adding 3 cars. So we get down here to cars, add car. Sure enough, we receive the car, and it gets added to our cars array list. So we added our people, we added our cars, and now we say print status. Let's try this. I'm going to compile this. I'm going to run it. So what we did is down here when we call print status. I want to look at print status. Now, where do I find print status at? Well, print status is of type dealership. So if I go to dealership, it brings it up right here at the bottom. Now, you'll notice it shows the company right here. OK Used Cars. Then it has a tab, so you notice between cars and Eric there's a tab. Then it gives me the manager's name. Then it shows my salespeople and all my cars. Let's add another car. I'm going to add a real car. Actually, rather than do that, I'm going to copy this one. I'm going to add both of my cars. I have 2 cars. I have a Volt and a Prius. Okay. So what should happen when I run this program now? Now I should have the same number of managers, or I'm sorry, salespeople, but more cars. Sure enough, I still have Curtis and Jordan, but now I have an Accord, Civic, CRV, Volt, and Prius. Could I make it a little better? Yeah, I could go into my print status, and I could say, let's go. There. I'm going to put a /T. No, I'm going to put a /N. Sorry. Now let's run it again. There. Now it has the dealer, and it shows my salespeople. Now let's go in, and after this first for loop, I'm going to say cars. Now this /N is basically telling you to give me a blank line before it. There it is. There's our dealership. There's our salespeople. There's our cars on the lot. Get our 5 cars. Okay. Hopefully you understand that. Let me take a break for a. Actually, let me go through. Okay. Let me take a break for just a quick second. Inheritance. Okay. Let's talk about inheritance here for a little bit. Okay. Different ways of creating items. We already talked about aggregation. We already talked about composition. But inheritance is another way, and we're going to see examples of this. All right, it says you could create independent design blueprints, manufacturers, 5 cars, so on and so forth, but you could inherit them even easier. Okay, what if one design type, or what if you could create something like maybe tires, 4 tires? Don't all cars have the same kind of tires? So you can inherit tires into your program. Now, this is creating a more specific blueprint that's based on an existing blueprint is a negative list for creating inheritance. And we're going to look at an example of that in just a second. Okay. All right, it says there inheritance is very important to Java. Okay. I think, okay, hopefully this recording is still working. Okay. Here is an example of people, customers, employees, full-time, part-time, and so on and so forth. Okay. We have a person class that has name in it. Then we have customer with an address, employee with an ID, full-time, part-time, so on and so forth. Okay, it says the person contains data and methods that are common to all classes. Okay, so the customers also need a name. Employees also need a name. Part-time and hourly both need an ID plus a name. So it goes on from there. Okay, so let's talk about some of the different terminology in here. It says with inheritance, for each pair of linked classes, the more generic class is called superclass, and the more specific is type subclass. So looking at this example, the person at the top is the very generic. So that would be the superclass, and the customer would be the subclass. Okay. It says the subclasses are derived from the superclasses. They inherit all the capabilities of them. Okay. It says unfortunately the term superclass and subclass can be misleading. Super as the superclass can imply that superclasses have more compatibility. No, that's not true. But that's just how it works. Sorry. Okay. It says the programs often refer them as parent or base class when they're referring to superclasses. So this person at the very top, the person class, is really the base class or the parent class. And then the customer and employee would be the child's or the derived class. Okay, let's continue on. All right, UML diagrams. We actually just saw one right there. There's our UML diagram. Okay, not necessarily required, but a lot of people do them. Okay. Now at the bottom, actually, there's something here that's kind of important. They talk about what is the minus sign for. Well, the minus sign is public or private. Okay, minus is private, plus is public. Okay. All right, in the third compartment, that's where we put our method headings. And I think it's not going to show us. I guess he's not going to show us an example one. Okay, there it is. Okay, yeah, the third box here. Let me bring my mouse in here. So we have the person class. We have a private variable called name of type string. Here's where we could put all of our methods if we were to do stuff like get name, stuff like that. Okay. All right, benefits inheritance helps with code reusability because you can use the same thing over and over and over. Okay. Smaller modules. Okay. It says the superclass's code can be used for multiple subclasses. Eliminates redundancy, but that doesn't mean just copy it from your partner. Okay. Program can use an existing class to easily create a new subclass. We could also have smaller modules. Okay, we're going to see an example here in just a second. Okay. All right. It says implement a person superclass with an employee subclass. We're going to walk through all these and I'll show them to you. Okay. The person should have a name variable. Okay. We should have some constructors for it and a get name accessor method. The employee should have a inherit from the person. It should declare the name variable because remember prior we showed employee had the ID, person didn't. Okay, and then we also define appropriate constructors and have a display method. Okay, now let me bring the code in. I already copied the code in here so you can see it. All right, person right here. Okay, here's our superclass person. Has name but no value. Has a constructor with not much in it, and then we have a constructor with something in it. Now, this is the default constructor. Really doesn't do anything. So we could call this a new person. Just wouldn't do much. If we call it new person passing it a name, well then the name will be set right there into name. And there's our accessor method, get name, to get the name. Now let's talk about employee. Okay. I added a little bit. Actually, let me go to the slides, make sure. Okay, there's the class employee. Okay, I have the same one. Mine's. Oh, I lost my toolbar. There it is. Okay, mine's a tiny bit different from what he has on the screen. I added some code to it, but you'll see at the very top, public class employee extends person. What that means is employee takes all the functionality of person and uses it. Okay, we add the ID. Then we have our constructor. Then we also have another constructor. Okay. Now this constructor receives name and ID. Now you'll notice over here on the left, he doesn't have anything in his. But you guys aren't here where I can ask you questions, so I'm kind of doing it for you. But with our constructor, okay, we receive the name and an ID. We can set the ID very easily because we have the ID right here. Okay, ID is 0, so we can set the new ID value because this ID goes right here, it gets set up in ID. Now we got a problem with name. We can't set name because we do not have a name variable up here. And if we created another one, we'll kind of be overriding the other one. So what do we do? Okay. Well, you'll notice here, go back one, no, right there. Sorry, we have the name variable in person. And since employee extends person, how can I use that name? Well, a lot of you would change this one over here. You would change that private to public. Not a good idea to do. Don't do that. Okay. What you can do though is you can use something called super. Talk more about it in a second. But what that does, actually I'm going to put it in the wrong place, just so you can see what happens. Okay. So the first line will set the ID, and then name right here. Super says pass it to the super class, and find the method that receives a variable of type string. And sure enough, we have a method right here. We have a constructor that receives the name. So just by calling super is actually going to be calling this constructor as well. So this line would save the ID, and this line would save the name. Now there's a problem. I go to compile it, it's like, okay. It says error, call to super must be the first statement in the class. So if you're going to be doing that, we need to do this right there. Actually, I'm going to show you something. I'm not sure if all of you know this. You can actually take code and drag it as well. Okay? You can very easily drag it. Okay, so now what happened is name gets sent to the constructor for the person, gets saved, then ID gets saved, and then it'll work. Okay? We also have the display method. Now the display method, we can just say this.id because it's right here. ID is local to this class, so we can do that. We can't just say this.name because name is in the person class. So what we need to do is call the accessor method getName. Okay, let's try running this. Whoops. Why couldn't I run it? Anybody have an idea? Okay. I can't run this. How come? Does anyone know why? Can I run this one? Let's try this one. Can't run that one. And I can't run that one. Why can't I? Because I have no main method. Okay. Neither one of these have a main method. I don't know if he created a driver for this. Okay. Not important. You don't necessarily need one anyway, but now you know what the classes look like. Since name is private, we can't access it, so we have to use super to get that. Okay. We can use, they should mention here somewhere. There it is, super. Okay. A constructor may call a constructor in a superclass by using the syntax super in the arguments. Okay. It says a constructor call is allowed only if it's the very first line in the constructor's body. This rule is applicable to constructor call. Okay, so we pretty much talked about that already. Okay, let's continue on. Okay. This is now calling a superclass's method from within, like getName. We can just do that all by itself. Okay. You don't need anything. It says, if you call a method that's in the names class of the class you're currently in, the reference variable .prefix is unnecessary. Okay. Since we inherited person, we do not, or actually, yeah, we extended person, we do not need to include that. Okay. Now, pause for a second. All right, I'm actually going to pick this up in another recording.